So for today, we're going to take what we know about logarithms and combining them or expanding them into solving logarithmic equations. So instead of ending up with an entire expression at the end, all of our answers today are just going to be a single value. All right, so let's start with this one. This one's a little bit tricky. Log base 6 of x plus log base 6 of x minus 9 equals 2. So I want to get this down to a single logarithm. Since these have the same base, I know I can combine them. Since they're being added together, we know that's our product rule. It's spaced out there. So it's going to be log base 6, and then I'm just going to multiply x times x minus 9, and all of that equals 2. Okay. Let me just do a little bit of algebra here. We're going to distribute this x out. So this is going to be log base 6. X times x is x squared. X times negative 9 is negative 9x. Still equals 2. Okay. So at this point, we have one logarithm. And then we go back, we think, how do we rewrite a logarithm in exponential form? So you look back at your notes from last Monday, and remember if it's log base 6, then the base of my exponent is 6. We take the number on the right-hand side, that becomes our power, so this is 6 squared. And the number after our logarithm, that becomes the right-hand side of our equation. So all of this, we put on the right-hand side. Okay? And that's how we convert from logarithmic to exponential form. And then at this point, this is algebra 1. This is just a quadratic equation that we need to solve. So I know I need to bring this 6 squared over. Actually, let me bring that to a new column here. So this is going to be x squared minus 9x minus, right, because it was positive, we bring to the other side, negative 6 squared is 36, and all of that equals 0. So we're solving the quadratic, so I'm going to look for factors first, since I know all my answers are integer values today. I know this should factor out. So what multiplies to negative 36 and adds up to negative 9? That's 12 and 3. Since our middle term is negative, that means the higher number has to be negative, so minus 12 and positive 3. And then don't forget, I know you do all this work and then you skip this final step. If these are my factors, then the solutions are the opposite value. So x either equals 12 or x equals negative 3. Okay? And then we have to remember, if we take the logarithm of something, it cannot be a negative value, right? It has to be something positive. So we can substitute our answer choices into either of these amounts after our log base 6. And nice and easy, since we just have log base 6 of x, right? We can say any negative number, that can't be it, right? You can't take log base 6 of negative 3. That's it. There's my whole check. So x equals 12. That is my one good solution for this question. Okay? So that's one kind of problem you're going to see. There's two cases we're looking at. So let's take a look at the other. This is the harder of the two. BT dubs. Our second case is, what if we have a logarithm on either side of our equation? Okay, so if that's the case, we need to simplify as much as we can. So on this side, 2 log base 7 of x, since we have a coefficient, we can move that to the power. So we can say this is log base 7 of x squared. And on the right-hand side, we have 2 logs being added together. So that's our product rule. So this is log base 7 of 27 times 3. And 27 times 3 is it 81? Wait, I don't know what 27 times 3 is. 1, 2, that is 81. Okay, 81. Okay. So now we've done this, we have the same log base on both sides, which means that these two values must be equivalent, right? So you simplify all your logarithms down, so you're just left with some log base something, and the same log base on the other side, and then you can take those two values, make that your equation, and then solve for x. And we can probably finish this one up, since either you need help with this or you already know the answer. If we want to get just x, we would take the square root of both sides. So x would equal plus or minus 9. And again, to check that, we put this 9 or negative 9 in, well, there's only one x here, right? I can't even look at the right-hand side. But again, since it's just x, right, we can't use the negative 9 because we can't take log base 7 of a negative number. So our only possible solution is the positive 9. Okay? So whenever you get your answer, substitute it back into, and a lot of these are pretty simple. We see just log of x, log of a. So our checks won't be too much work. All right, so try them out. It's really just practice of what we've been working on the last couple of weeks. Hopefully it goes well. All right, good luck.